2, 1. All right, so welcome back. I talked about the video relating triangles and quadrilaterals and the different types that you have. I'll put a link up above because I went through those, but I wanted to include them here because this is a follow-up video where we're basically going to take certain points on a Cartesian plane and then trying to figure out, based on those points, which kind of are your vertices, under what kind of a triangle or quadrilateral can we form out of those points. So here's the list of all the different triangles and then all the different quadrilaterals that you have. And now what we want to do is we want to be able to face a question like this, where someone gives us basically points somewhere on the Cartesian plane or the x and y axes basically, and then asks us, okay, what kind of a triangle is this? So we know that it's a triangle, but then which one will it be? Is it going to be equilateral? Is it going to be an isosceles triangle? Is it going to be an isosceles right triangle? And so on. So I'm going to try to show you, okay, so how you can go through that particular step process. And in order to do that, you basically need kind of one important concept, and that is figuring out the length of line segments. Now, I have done the video on the length of line segments. I'll put up a link up above to that video, and you have to know that before you attempt these. So the idea is, all right, so if I can figure out, okay, how long a line segment is on the Cartesian plane, and we can certainly do that, and then I can try to see, okay, which particular sides of, let's say, a triangle are the same, then I can start thinking about, okay, is this an equilateral triangle where all the sides are identical? Is it an isosceles triangle? Okay, or is it just nothing is in common? It might be a scalene triangle. So that's something that we will do. Now, for quadrilaterals, when we're going to do another example for that, it's going to be a little bit trickier because there we're also going to need to see, okay, which sides are, for example, parallel, which sides are not parallel. We may want to be able to see between two line segments if they're perpendicular to each other. So you have to know and understand slopes. And those are the tools that we're going to use. All right, so let's kind of get started. So obviously this is a triangle. So I'm going to draw this triangle out in here. So here's my triangle. Okay, so it's between all of these, and this is all nice. And maybe I would be able even to tell just by drawing what type of a triangle this might be. So what we will want to be able to do is we're going to be trying to find how long each line segment is. Now recall that if you want, so just for a general line segment, the formula basically is you take the x values, you will square them, and you'll take the y values, so the difference between the two, and then you'll square those, and then you take the square root of that, and then you know exactly how long this line segment is. That's just by using Pythagoras theorem, and that's what the video was talking about before. So I'm going to use this and calculate it for each of these lines. All right, so I'm going to do it in kind of fast forward motion, okay, for each particular line. So that's the length. So it's the square root of 26. I'm not going to write it out as a decimal yet, all right, because I want to be able to compare all of them. Let's try now the second one. So that's the first one. I'm going to take now the second one right here. Let's do that in fast forward motion. All right, so we have our second one. Now notice they're not the same. So therefore these two sides are a little bit different. Okay, so one is longer than the other. So we can't make any conclusions as of yet. But we know that it definitely will not be an equilateral triangle, meaning where all the sides are the same. So let's see if it's maybe an isosceles triangle. Okay, so let's try the third one, again, in fast forward motion. And that's our third one. Now notice that in here, so these two are identical. So the first one and the third one is identical. Put here 3. So we have two sides that are the same. So that means we have some kind of an isosceles triangle in here. So this one and this one. Now, we would want to be able to see, all right, is this a right, okay, triangle? So is this an isosceles right triangle? That would mean that we would have, so within here, that this angle right here would have had to be 90 degrees. Now, you can probably kind of tell, okay, that it's not going to be 90 degrees, but, okay, we can actually test that out. Now, how do we test that out? Well, we test it out by simply taking those two lines, so line 1 and line 3, now that we know that they're identical to each other as line segments, but we can take the slopes of each lines, and then we can figure out if the slopes, all right, so if we take our test for the slopes, so if we have slope of line 1 and then multiplied by the slope of line 3, if this is equal to -1, then we know that they are at a 90-degree angle. So we can test that out. So if we take these, so I'm going to create what the slopes are for each of them, and then we're going to run this test for ourselves to see if that's a right angle triangle. And if it's not, then basically we can conclude that this is just simply a regular isosceles triangle. Now, if it was a different type of triangle, so we could go along this list and then see, so if there was nothing in common, it would have just been a scalene triangle. If all the sides were different, but we had a 90-degree angle somewhere, then that would have been just called a right triangle. Notice that then there's the isosceles triangles. So we're basically saying that we are going to be something within here, all right, because that angle is not really 90 degrees for us. Okay, so I'm going to show you that. If all the sides were the same, then it would have been an equilateral triangle. And that's how you can test for yourself which triangles you have if somebody gives you a Cartesian plane and then just starts plotting either a triangle or points and asks you, what do you have? Can you identify this triangle? So let's try in fast forward motion. I'm going to show and derive the actual slopes for this particular triangle. And if you forgot about slopes, of course, you can kind of look it up, but slope is just simply rise over run. Okay, so I've created videos on that as well. That is in the grade 9 content, so you can take a look in that playlist. So here we have, so I'm going to do M1 and M3. So there we have it. So we have our slopes, which is 5, and then the other one is 1 over 5. Notice when we multiply them, we will get 1, but we will not get -1, which would have shown us that they're actually at a right angle. So this triangle is simply just an isosceles triangle. So that's what we have in here. So that's the first example. Now let's take a look at another example. So what if you have something of this nature? And somebody gives you and plots these particular points. Now notice, because we have 4 points, kind of 4 vertices, so this is some kind of a quadrilateral. Now, which type of a quadrilateral is it? Is it just a simple square, where all the sides would have to be equal, and then the angles between are 90 degrees? Is it maybe a rectangle, right? Is it maybe some kind of a trapezoid? What is it? So let's take a look. Now, how do we go about finding what this is? So of course we can guess, but we can also find, again, the length of each sides and then try to see and compare. We can also see and compare if the opposite sides are parallel to each other. So we would have to find the slopes in between and then see what happens there, right? So let's take a look. So my first step is going to be, I'm going to try to see if maybe the quadrilateral that we have, so this one, I'm going to draw it out in here. So I'm going to connect all the points in here and then see. All right, so what does this kind of look like for myself? So visually, that's what we have there. And let's now take a look. Now the sides, it looks like they're kind of different, right? So we're going to try to see if any of the sides are identical, or maybe they're not identical. So let's dive into that. If you can't see it visually, you would have to calculate it. So I'm going to calculate all the sides, again, just by using the length of a line segment. So I'm going to do that all in fast forward motion, and I'll do it for all 4 sides just to show you, right, that the sides could possibly be different. All right, so see you back in a few moments. So here are all the different sides. So notice there are 2 sides that are identical, which is 2 and 3. Well, that's these ones right there. But that's not enough for us to make any kind of conclusion about this. So it's clearly not a square because the sides are not the same. It's not a rectangle in any ways. Okay, so that we can see as well, because in a rectangle you would have the opposite sides being equal. So it's none of those. So let's take a look and see what could it possibly be. Now, within here, so we can rule out a square. Certainly not a rhombus, because all the sides would have been equal to each other. So that can't be it. Now, is it a parallelogram? Well, it's not a parallelogram because, again, the opposite sides, like in a rectangle, are the same. So that can't be it. So that leaves us basically, it's either a trapezoid of some kind. Now, it will not be an isosceles trapezoid because the equal sides have to be opposite each other, as you see there, and then the other ones would have to be parallel. So is it just a regular trapezoid? Is it possibly a kite? Well, that can't be a kite because, again, notice that the sides would have to be the same. So the 2 joining sides on top and then the 2 joining sides at the bottom. So it's not a kite. And so that might just simply mean that it could be just a regular irregular quadrilateral. So is it irregular quadrilateral or is it just a regular trapezoid? Is there anything which is parallel? Okay, so let's take a look if the 2 sides are parallel here. So I can take these. Now, just because the sides are all different doesn't mean that the opposite sides are not necessarily all parallel to each other. Now, visually, I can probably tell and say, no, not really. But let's do a test, right? Just to kind of make sure. Now, how would we test for parallel lines that are opposite? Well, we would need their slope again. So in order to get their slope, so if it's these ones or if it's these ones going in this direction, we would need the slope and then see, are they identical slopes? So I'm going to just do one pair, right? Just to show you that they're not the same. All right, so we'll do one of these pairs. So I'll do this pair, for example. And then, just for good measure, we can do the slopes of these 2 and then show you that nothing is parallel. And then that way it would show you that it's just a regular, it's an irregular quadrilateral. That's it. That's what you would have. So let's take a look and see, all right, what happens there. So here are the slopes, all right, so of the opposite ones, and notice they are clearly not the same. So that means that for this example, this is nothing else but simply an irregular quadrilateral. And these are the steps that you would have to take and go through. So it's a little bit painful because, as you know, I sped these things up so that you can see them a little bit clearly and faster. But if you had to do it on your own, you would have to do quite a little bit of work to try to see and identify which one you would have. All right, so thanks for watching and we'll see you in a future video. Bye, everybody.